A very good evening, everyone. Myself, Shauradip Odhikari. A very warm welcome to all the distinguished
Call is
participants,
now being recorded.
respected guests, and enthusiastic learners who have joined us today. On behalf of Modak Trainer Academy, I am truly delighted to welcome you all to this intellectually enriching webinar on dental remains in archaeology, significance and applications. Today's session opens a fascinating window into the intersection of archaeology and forensic science, exploring how something as small and resilient as a tooth can unravel powerful stories about human evolution, culture, diet, and even identity. We are deeply honored to have with us distinguished young scholar, respected Asmita Shikdar, a research scholar from Deccan College, Pune, currently pursuing her PhD in forensic dentistry. Her academic brilliance and research accomplishments speak volumes of her dedication to archaeological and biological anthropology. She has presented papers at several international conferences and published her work in reputed journals, including the American Journal of Biological Anthropology. She has presented her papers at several reputed universities and colleges, nationally and globally. She has written several books also, including Footprints on the Chrome Lakes, an archaeological perspective on food, diet, and health in megalithic South India based on the skeletal inventory from selected sites, etc. She has been awarded with several prestigious awards by reputed colleges and universities. She also directed one film titled as Solace. Her scholarly journey reflects a blend of scientific precision and deep curiosity about human history, qualities that make her insights truly inspiring. Through today's session, we look forward to understanding how dental remains not only assist in archaeological identification but also play a vital role in forensic investigations, helping bridge the gap between ancient and the modern. Let us now join our hands to welcome our today's esteemed speaker, respected Asmita Shikdar, and dive into this fascinating exploration of dental remains in archaeology, significance, and applications. Thank you.
Should I begin?
Yes, ma'am.
Okay. So, at the very beginning, I would like to thank Modak Trainer Academy for asking me to deliver this talk. I would just share my screen. Okay. Is the first slide visible?
Yes, ma'am.
Okay. So I would be speaking briefly about dental remains in archaeology, significance and applications today. To begin with, archaeology is the science of reconstruction of the past through material remains. Now, whenever a site is excavated, we do come across several kinds of remains. The very first kind, and the one that you can see here, are structures, and it can be of different kinds. There could be domestic structures, there could be hearth signifying cooking. There could be wealth. There could also be majestic structures like the Great Bath at Mohenjo-daro or the Citadel, which were the earliest sites to be discovered in the Indian subcontinent and which had placed India on the global map of civilizations, affirming that India too had a very ancient past comparable with contemporary civilizations of the world. Earlier to that, it was believed that India's past began much later, somewhere around 4th or 3rd century BCE. So, alongside these structural remains, we also come across a number of cultural remains. For example, pottery, which could be painted, designed, or carved in different ways. So, this image on the left-hand side shows pottery from the site of Sanauli in Uttar Pradesh. Again, we can also have different kinds of artifacts. For example, here we have some ornaments from Harappan sites, which include beads as well as copper-made ornaments, which tell us about the cultural facets of ancient human life. Apart from these, we also come across large number of animal bones and human bones, which might enable us to infer something about the paleodemography. Now, paleodemography is the science which tells us about the people of the past, indigenous communities. Paleo meaning old and graphein means the science. So here the images contain a number of crania of ancient individuals. These are mandibles or the lower jaw. We also get a large number of bones. Here, this is a crania from the site of Pokrapur in Maharashtra, which was an accidental find. So these remains are transported from the site carefully to the laboratories. They have, as you can see, a lot of sediments. This was actually wet mud sticking to it. So they have to be cleaned before we can study them and infer something about the ancient ways of life. These are the segregated bones. Here on the left, you can see the bones of the lower extremity or the feet, and here are some bones from the upper extremity or the hands. We also have other bones like this is the scapula or the shoulder blade. Here we have some ribs, etc. And this is how these are actually cleaned using brushes, etc. in the lab. Often the bones are very fragmented and they actually have to be fished out of the sediments in order to study them like this. So these are some clean bones which can henceforth be studied. These are some images of the ancient burials. This image on the left hand side, it is from the site of Mahadaha in UP, a Mesolithic site. This image on the right hand side, you can see two individuals buried in a single burial from the Chalcolithic site of Inamgaon. And there are some grave goods like pots, etc., which was an ancient custom there, affirming ideas about afterlife. And this image at the bottom, this is an individual from cemetery R37 in the very well-known site of Harappa. Now, when we are trying to infer something about paleodemography, we have to determine variables like age and the sex of the individuals. We can also find out other aspects about their life and culture. So the significance of the teeth come in here, and they are so important in the study of indigenous communities or archaeological material, particularly pertaining to biological remains, that this very well-known paleontologist, Baron George Cuvier, once said, "Show me your teeth and I will tell you who you are." So what are the different kinds of data that we can gather from teeth of human beings? The very first indicator is about their food habits, because depending on the type of food you eat, there are bound to be certain markers left behind on your teeth. If an individual consumes a large amount of hard seeds or food that require a heavy amount of bite force, they are likely to cause a lot of abrasion and even attrition at times, which might wear away the surface of your teeth. Just as you can see here, the upper layer of the teeth comprising of the enamel have been worn off completely, exposing the dentine beneath. Again, with the transition to agriculture, when people started consuming a lot of food rich in carbohydrate or starch, they began to be the cause for dental caries. Like here, you see, although this is a modern teeth, these are modern teeth, but still, these are caries. And it also comes with consumption of a lot of sugary food containing sucrose. So, this is one indicator. The second is indication about their occupation or trade, because various indigenous groups we know are given to basketry. They tend to prepare baskets or use a lot of tools or weapons which require weaving with the help of straws or strings. Now, if an individual is engaged in some kind of trade for several years, say 10 or 20 years, because they would begin these trades right from early adulthood and continue this till old age. So, after doing this throughout your life, you are bound to leave behind some kind of markers on your teeth, which can tell us what kind of activities these people might have been practicing for livelihood or even sometime in leisure. So this again is from the same individual from Pokrapur that I had shown. Here you can see in the image on the left hand side, the teeth have a high amount of lateral abrasion. So these are very unique, not found very commonly in dental remains that we have seen so far. So it states that he must have been engaged in some kind of trade or tool making that required tying something around his teeth, which had heavily eroded his teeth in this manner. Next is the cultural modification of teeth. Again, teeth form a part of the facial aesthetics, and the ancient communities, particularly, are known to decorate or embellish their teeth with lots of precious stones and sometimes even gold, as you see here. Often, it's not just an embellishment, it might also be a marker of puberty, that is, the transition of an individual from childhood to adulthood. And such dental embellishment is also done to mark the ceremony. Here in this slide, it's an image of an individual from the ancient Maya civilization in Peru, which likely dates back to 500 to 900 AD. So you can see the teeth have been decorated with precious stones, and often such treatment of the teeth may also leave behind notches. They are also known to damage the teeth in certain ways, which might also act as biological proxies. Now, coming to the health profile. So, just as the teeth tell us about cultural practices or traits, they also can give us an idea about the biological profile of individuals. For example, there is a very important chalcolithic site in Maharashtra, in Amgaon, where we have lots of infant burials. That is, children of the age between 0 to 5 years have been buried in large pots. So, this states that there was a lot of infant mortality because the children were suffering from malnutrition. And when you study individuals with malnutrition, you might find such linear patterns on their teeth. This is known as dental enamel hypoplasia, which is actually a kind of degeneration of the dental enamel, which occurs when the teeth are not supplied with adequate nutrients or minerals needed for their upkeep. So these people settled in Hinamgao around 3,500 years back were early farming communities who had taken to settled life. So probably these people were not yet producing sufficient food to feed the entire clan, and hence there was malnutrition. This has been observed across other civilizations in the world also. So now I'll be coming to another aspect of application of dental remains in archaeological research, that is aging, that is finding out the age of the individual from dental remains. So before that, I'll just give a brief outline about the anatomy of tooth, because that is important for the next part of the talk. So this is a typical human molar. This upper white part, this is the enamel, and this gray part continuing beneath it is the cementum. Beneath the enamel, this yellowish portion, it's the dentine. And here, this pink portion extending below, it's known as the pulp cavity or the pulp chamber. Here you will see the nerve endings and the blood vessels, which are responsible for supplying the different nutrients, minerals, etc. to the teeth. So the teeth, and particularly the enamel, are the hardest tissues in the human body, known to survive the onslaughts of time and natural agencies for very long periods of time. That is why they can act as very important biological proxies when it comes to research. So the phenomenon on which this method of aging is based is dependent upon the size of this pulp chamber. There are other methods of aging from dental remains like the attrition levels, etc., known earlier, but this is a relatively less studied method. So this canine that you see, this canine B on the right hand side, it has a fully developed pulp chamber marked by the red portion. And this canine A on the left, it's the teeth of the same individual. But if canine B denotes the age as 20 years, this canine A is the tooth of the same individual at a later time, say the mid-40s. That is why the pulp chamber has been truncated, the height has been shortened due to the deposition of secondary dentine here. This dotted portion is a secondary dentine. It occurs with the increase in age. So as your age increases, the size of the pulp chamber comes down. This phenomenon was first observed by a scholar named Bodekier in 1925. Later on, it was worked upon by others naming Solheim, then Drusini in Italy, others in Western Australia, Iraq, etc. There have also been attempts to use more detailed and better result yielding methods like microcomputer tomography, etc. However, most of the studies have been limited to the modern population, that is, people who are still living. There have been very few attempts to apply it to the archaeological population, which I have tried to do in my research, and I have tried to keep the methodology as simple as possible. So coming to my materials and methods, to begin with, I had collected the dental X-rays of living individuals from the cities of Kolkata and Pune and their suburbs. So the sample include both mandibular and maxillary teeth, that is teeth of both the upper and the lower jaws of males and females of known age. That is, I must know the age of the individual when the X-ray has been taken. And the age group was restricted between 20 to 70 years for the living. Now, using these X-rays, I calculated these two, a ratio using these two measurements. So these are three images. This is a molar, this is a canine, and this is a premolar. So these are the two heights that I have taken. CPCH is the coronal pulp chamber height, which you can see here is the distance between the line joining these two horns and this portion, which is called the cemento-enamel junction. This is the perpendicular distance. CH is the coronal height, which extends from the tip of the highest cusp of the teeth to again this same cemento-enamel junction, this line. So these two measurements have been taken for each tooth, and they have been used to calculate this index known as the tooth coronal index after Ikeda et al.'s formula, coronal pulp chamber height into 100 divided by crown height. Now, having made these calculations, I used them to build three models for every kind of teeth using a statistical method named regression, which basically tells you the relationship between two variables. So having built those models, I tested them on another set of teeth, again taken from the living population, and when I succeeded, I applied them on archaeological samples. So I have used these kinds of X-rays. These are called panoramic X-rays or orthopantomograms. Panoramic because you can see the entire mouth, also known as the buccal cavity. You can see here the pulp chamber. They are very clearly visible, and each tooth is also distinctly marked. So this is a very clear example of an OPG of a 26-year-old. However, a word of caution, that is when we are counting teeth as samples, we should leave behind teeth with histories of medical intervention. For example, here you see a tooth with an implant. This pulp cavity has some kind of filling. Again, here, this tooth has some kind of a cap. Here you have other implants. So such teeth cannot be considered as samples because medical intervention completely mutilates the pulp cavity and they are of no use to a researcher. So this was my sample size. From the living population, I had a total of 217 individuals, 102 females and 115 males. And again, from the archaeological specimens, I had a total of 32 individuals, 13 females and 19 males. So this is an instance of an archaeological specimen from the site of Daimabad in Maharashtra. So Daimabad has several cultural layers, but this individual comes from the late Harappan period. That is, it's roughly around 3.5 to 4,000 years back. So these are the three models that I built using regressions. So this line basically gives you the relationship between the two variables. Here you have age and the tooth coronal index. So with the increase in age, your tooth coronal index comes down. These models actually give you this kind of an equation. So your X is the index, the tooth coronal index, and Y is the age that is predicted from these equations. So these are the ones for canines and molars. So having created the models, as I mentioned earlier, I had tested them on another set of samples from the living population to see how far these models were successful in predicting the age of the people. So in case of molars, I had an age bracket of 6 to 8 years on an average for every individual. For example, if the age of the person is around 24 years, I am getting an age bracket of 22 to 28 years from the different teeth. Only about 6% were differing by plus minus 10 years. In case of the canines, again, about 8.9% differed by plus minus 10 years, and in case of the premolars, about 10.89, that is 11% cases differed by plus minus 10 years. So when I found that these equations were successful in predicting the ages of individuals with considerable accuracy, I tried to test them on archaeological specimens. But before that, I had also compared the indices, the average indices from the Indian subcontinent for every age group. That is, this is the age group 20 to 29, 30 to 39, with the average indices of other countries, those that have published their data. So you can see that they are pretty close by. Here it's 29.85, that is 30. Here it's 34, it's 31. Here it's for 40 to 49-year age group, it's 20 almost. This is 21, this is 22, like that. This is for the molars. This is again for the canines. Again, you have a very similar average here. For India, it's 35.46. For Italy, it's 34.6. So about 35. So it suggests that even in West Asia and the Mediterranean region, the indices do not differ a very great deal in spite of the climatic differences and the food habits. So this index depends less on food habits. So having done that, I tested them on 11 archaeological sites. I have made a list of the sites here, but I shall explain them from the map. So the individuals from all these sites have been formerly aged by other scholars using different methods such as the attrition levels and epiphyseal fusion of the bones, etc. These methods were primarily used for finding out the ages of the individuals. So the first site is here, Choskar in Kargil district of Jammu and Kashmir. It's not a habitation site, that is, it's not found from the location where people actually live a settled life. This was an accidental find from underneath the debris where two individuals have been buried accidentally due to debris fall. So it was discovered during road construction and it's roughly 100 years old. Then we come to the very well-known site of Rakhigarhi in Hisar district of Haryana, affiliated to the Harappan culture, from where we have a few individuals. So this site is between 6,000 and 5,000 years before the present. This is the site of Sakas. Here it's mostly early farming communities between the Neolithic and the Chalcolithic phase, that is people who have just started living a settled life. So it's again roughly 3,500 years old. Then it's Balupur in the Malda district of West Bengal, where the dates are between the 7th century and 18th century in the Common Era. So coming to Maharashtra, here we have the site of Nevasa, which is a very important Chalcolithic site which has several cultural layers. But the two individuals that I considered from this site, one comes from the Chalcolithic phase, that is the Copper Stone Age, and another individual comes from the Indo-Roman period. Here again, I have the site of Daimabad, again in Maharashtra, which I mentioned earlier, the late Harappan site. Then I have the port site of Chaul, also in Maharashtra, which belongs to the Indo-Roman period. We have other cultural layers, but this is the individual which I considered comes from the Indo-Roman period. So roughly between 5th century BCE to 5th century CE. Then we have the accidental find from the site of Pokhrapur, which I mentioned earlier. It's a medieval individual around 400 to 500 years old. It is also an accidental find from a construction site. Then we have the site of Chinnamarur, presently in Telangana, Mahbubnagar district. This is a megalithic individual about 3rd century BC. Now, megalithic sites are named so because the inhabitants of the site are known for building very extensive burials comprising of huge stone structures. They are also farming communities. Then we have the site of Tekkalkota, again a Neolithic site from the state of Karnataka. So they are also early farming communities, about 3,500 to 4,000 years old. Then we have the site of Kodumanal in Tamil Nadu. Here also we have a number of cultural phases. We have megalithic burials between 3rd century BC onwards, and we also have the Indo-Roman levels. So this is the age profile of the archaeological specimens that I considered. You can see that most of the specimens are aged between 40 to 49 years. So their life expectancy across these time periods was on an average around this age group, because people did not live so long as we do today during these periods. So now I would show you a few images of the mandibles that I considered for the research. Here I have only mandibles in images and the corresponding x-rays. So this is from the site of Choskar, and this is the kind of x-rays that I had taken for these. This is from Sakas. This is Nivasa. And again, the corresponding X-ray. This is Chol. Here. So after having measured the pulp cavity dimensions of these archaeological specimens, I had applied them using the same equation. And here I would present two examples of how well the age predictions have come out to be. So these are two individuals, SK8 and SK3 from Rakhigarhi. And their predicted age earlier by the former scholars who had studied them was 30 plus minus 2 years. That is, the individual was taken to be between 28 and 32 years. So my equations gave me these three ages respectively. From the molars, it was 31.61, so roughly 32. Canines, it was 33.36. Premolars, it was 33.51, so 34. So the earlier age was 28 to 32 years. I got between 32 to 34 years, so they're very close by. And again, I'm having a 6-year age bracket. So this is again SK3. The formerly determined age was 30 years, and I got the age predicted from the molars to be 30.59, that is 31 years to 33 years. However, this kind of research has got a number of limitations. For example, accessing the data of living population, their radiographs are a bit difficult because this is not like asking them a few questions. It's an invasive method which is giving me their biometric data. So it's very difficult to collect. Again, archaeological specimens incur damages when they are being exhumated and transported to the laboratory. So in our department, we do have lots of specimens where the mandible is there, the teeth are there, but the crowns have been broken off in some way or the other. The pulp cavity is exposed. So it renders the specimen useless for the research. Again, for individuals over 60, this kind of method cannot be applied because individuals who are that old are bound to have a lot of wear and tear on their teeth, and the enamel is completely worn off at times. So if you take measurements on teeth which have so much damage, it is bound to give you wrong measurements. So to conclude, this method works very well for the age group between 20 to 55 years. This is moderately costly method which is not very difficult to be done on archaeological specimens, and it's useful for forensic dentistry, archaeology, anthropology, and it's giving us a tight age bracket of around 6 to 8 years, which is considerably good for archaeological specimens which are at times thousands of years old. So here I have covered quite an extensive time period, which can be around for a time period of 6,000 to 7,000 years. And I have also covered a number of important archaeological phases. I have Harappan, late Harappan, Neolithic, Mesolithic, Chalcolithic, Indo-Roman, medieval, as well as modern. So it can be said that in across this time period, the pulp cavity dimensions of the people in the Indian subcontinent have not been altered much. So, irrespective of the geographical regions that we live in, this method works. And also, when we look at the average indices of people from Italy, from Iraq, and there is also a country named Malawi in East Africa, the average indices for Malawi are not published, but the equation is given. And when I was going through the paper, I found that the equation is also very close to the equation that I got for the Indian samples. So this tells us that in spite of all the theories of eugenics and racial ideas, human beings still share a lot of commonality between them. So I would conclude the talk here, and I thank you for your time.